I started this project by using a concept I found on another YouTube video. It showed the unit circle and how it transforms into its graph form. And the video currently playing, I made a 15 block long circle, which is the units in Minecraft blocks. And I made each of the blocks on the perimeter go out one block each for 2 periods as shown. The graph starts at 1, 0 on the unit circle, which is when sine equals 1. As I zoom out, you'll see that it forms a sine graph. Now, I decided I wanted to start this build with a tower of sorts with this detail as its primary design element. But the regular sine graph is really stretched out compared to the base. The tower would have to be ridiculously tall for just one rotation. So I decided to multiply the angle value. Double angles result in periods that are half as long, triple angles cause 1/3 as long lengths, and so on. This multiplication of the frequency is shown by making the rate of change for the depth less. In the example shown, sine of 2 theta, every 2 blocks go out for 1 block. So 4 blocks on the perimeter results in 2 blocks of depth change, as opposed to the previous 4 blocks of depth change. This allows for more rotations in the same amount of height. The way I'm constructing the tower is by making 2 concentric circles, extending up the inner circle as a wall, and then taking up the outer circle to be the sine slope. I ended up using sine of 6 theta for the slope because I wanted multiple full rotations. Sine of 2 theta gives 1 in a reasonable height, sine of 4 theta gives 2, and sine of 6 theta gives 3, so on and so forth. 3 rotations I thought looked good for the height of the tower that I gave roughly. And I messed up several times actually while I was trying to build this, so the random block that is seen in the recording, ignore that, please and thank you. Due to what I want to do with the next part of the project, I don't want perfect rotations that start and end at the same point. So to find my new height that will prevent this from happening, I manipulated the average of pi to the nearest hundredth. I first multiplied pi by 100, but 314 is way too tall for the towers. Dividing this by 2 gives 157, which is a more reasonable number. For example, the average height of an American skyscraper is between 150 and 200 meters, which is what 1 block is. It's a meter by a meter by a meter. I wanted the tower to be split into 2 different parts, and 157 divided by 2 is 78.5. I'm going to slope the height of the tower from 78 to 79 blocks to help add to the broken in half look that I want. I didn't add the second parts of the towers until later, but you can see me adjusting the height of the bottom half. I didn't adjust the sloping effect. It just goes to 78 in the video, and then in the next video it's gonna have the slope from 78 to 79. But I did do it, I promise. I decided to use something similar to Roman arches to hold up the spiral. It's meant to be a pathway, and I've defined them as roughly a semicircle on top of straight pillars. Mine are more ellipsular, giving it a sense of parabola, kind of, but it looks very similar to the Tower of Pisa. This is also when I add the upper half of the tower. I'm starting the upper spiral at the point that the lower spiral ends and doing it for the same amount of blocks as the lower. At the end of the first layer and top or the bottom of the second layer, I took the 2 endpoints for where it goes from 78 to 79 and I made a line in between those. And then I went to the further point and made a 45-degree line to make a random triangle. I filled it with grass and the upper one with moss and some little glowberries to make it cute and kind of inviting. I now have 3 points from the tower, the entry, the exit to the second level, and the exit to the top. If I graph the circle with a diameter of 32, and each of these points, I'm able to construct a triangle by drawing lines between them. Finding diagonal links in Minecraft can be tricky since everything's in blocks, but I can get the horizontal and vertical links relative to the center very easily, allowing me to use Pythagorean theorem to get the lengths of the lines. Now that I have the line lengths, I can use law of cosines to find the angle lengths. The equation for law of cosines is c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle c. I can manipulate this equation to find the angle lengths, getting angle c is equal to arc cosine of negative c squared plus b squared all over 2 times a times b, where angle c is the angle I want to find, lowercase c is the corresponding line length, and lowercase a and lowercase b are the other two sides of the triangle. On Desmos, I put in the law of cosines equation thrice, and I rotated around variable angle C with angle A and angle B, and also rotating the side lengths around with it. This gives me the values for each of my angles, which are roughly 51.44 degrees, 31.13 degrees, and 97.43 degrees. Over the course of the project, I found that working with degrees is overall more efficient and easier for the nature of it, so I ended up staying in degrees the entire time. I constructed 2 more towers and walls in the same shape as the triangle that I made. I cannot use the angles in practice because circles do not exist in Minecraft. Using a 3-4-5 triangle as an example, it only takes 4 blocks to make the hypotenuse in Minecraft instead of 5. So I have to use the x, y, rise, and run values to make the diagonals, but the angles provide a great reference to help me make sure everything's okay. As for the wall lengths, I scaled up the original triangle lines by using a ratio. I was originally going to do 32 to 1 based on the length of the diameter, but that was going to be way too big, so I divided it by 4 to get 8 to 1, but that was going to be too small compared to the size of the towers. Doubling this gives me 16 to 1, which was in the Goldilocks zone. 24 to 1 or 20 to 1 might have been better, but I didn't have time, and it's like a week out at this point. So the scaled lengths of the legs are roughly 393, 260, and 499, rounded to the nearest whole number. To figure out the diagonals, I simplified the fractions using Desmos and found a pattern that worked. After this, I built the towers off screen. It took me a full day to do so and messed up my time plan, so I'm rushing at this point, but it looks pretty cool. I can tell that I built everything right because it lines up with the graph that I made. Expect a lot less video and more screenshots from here on out because I'm within, again, the last week or so at this point, and I am genuinely trying to hurry up and finish all this. To finish the walls, I had to make an entrance. I wanted to use a Greek character to use as the shape, and theta crossed my mind since it's so common, especially in trigonometry. But I decided to use omega instead because it looks cooler as a door, the shape's better, it's pretty open. I found the midpoints of each wall by averaging the x and y coordinates from the start and end points, and I worked from the center out. I only recorded the 45-degree angle wall, again, for time's sake, but I didn't, copy paste anything because I don't know how to copy paste and then rotate anything in Minecraft, so it's not copy pasted. Trust me. For the last part of my project, I wanted to add a couple buildings around to give the city some life. I conducted a short survey around my school with permission and also one of my online friends to get a radius and degree. This is polar coordinates. I got 13 responses overall, and with this data, I will convert the polar coordinates into rectangular coordinates that can be placed in Minecraft, and I'll adjust these coordinates for my offset center. To base them off the center, though, I had to figure out which center I wanted to use. If you didn't know, triangles have more than one center. A Google search can tell you much about each of them. One of these is the angle bisector center. Remember how I said that the angles that I found are just going to be for reference? I found out that that was a lie. I didn't know either. It's okay. This commenced the most frustratingly simple yet confusing part of this project. It had been 2 years since I last touched angle bisectors, and I couldn't recall how to find them. I was halfway through learning something called the weighted vector method using directional vectors when I realized I could just, figure out how off the angles are from 0 in each direction, and then subtract the largest one from the value. So if I have a 70-degree angle and I split it at 0 and I get 40 degrees and 30 degrees, well, 70 degrees divided by 2 is 35 degrees. And 40 degrees minus 35 degrees is 5 degrees. So that means that the angle bisector is going to be 5 degrees off from a zero slope. I did this with my angle A and my angle C, and did something similar with my angle B, but the angle B didn't have like a nice zero or undefined slope that I could use. Here's all the work I did for this as I entered the equations. I also found that B was actually negative, which makes sense in hindsight, and C had to have 90 added to it because I worked using x equals 0 instead of y equals 0. The center was found to be 1233 to the nearest whole number. With that out of the way, I can show you the clips of me getting the survey information. I changed the voices of each of the participants to the little robot voice that's all over the internet all the time, because I didn't tell them I was going to be posting it on YouTube, and I forgot to. So the words are the same, it's just in the little robot voice because I don't want to, like, make them uncomfortable.
Name a number 1 and 100.
66.
Name a degree angle number between 1 and 360.
189.
Name a number between 1 and 100.
67.
Name a number between 1 and 360 for the angle.
359.
Can you name a number between 1 and 100?
57.
Okay, can you name a degree angle between 1 and 360?
250.
Thank you. Can you name a number between 1 and 100?
95.
Thank you. Can you name a degree number between 1 and 360?
290.
You said 290? Thank you. Name a number between 1 and 100.
5.
Name a degree number between 1 and 360.
5 degrees.
Thank you. Can you name a number between 1 and 100?
65.
Thank you. Can you name a degree angle between 1 and 360?
360.
Thank you. Can you name a number between 1 and 100?
23.
Can you name a degree angle between 1 and 360?
21.
Thank you. Can you name a number between 1 and 100?
56.
Can you name a degree angle between 1 and 360?
90.
Thank you. Can you name a number between 1 and 100?
22.
Can you name a degree angle between 1 and 390?
90.
Thank you. Can you name a number between 1 and 100?
7.
Thank you. Can you name a degree number between 1 and 360?
98.
Thank you. Can you name a number between 1 and 100?
13.
Can you name a degree between 1 and 360?
311.
Can you name a number between 1 and 100?
57.
Thank you. Can you name a degree between 1 and 360?
67.
Thank you.
Name a number between 1 and 100.
A number? Just one?
One number.
25.
25. And then name another number between 1 and 360.
359. Now comes the coordinate conversions. First, I had to compile all of my data together. I didn't convert the degrees into radians because it was simplest to continue with degrees. The polar coordinates convert the same way into rectangular coordinates by using degrees, so it had no point to. My center is not a 0, 0, but I can add each of the coordinate values from the rectangular coordinates to the center's coordinates and move it without any issues. Coordinates on the unit circle are written as cosine sine. Cosine of theta relates directly to x since it's adjacent, and sine of theta relates directly to y since it's opposite, because SOHCAHTOA. Our cosine of theta will give me x, and our sine of theta will give me y, because this gives me the degree multiplied by the distance r, radius. Adding these values to the center coordinates will give me the rectangular coordinates related to my center. These are the coordinates I was given in my survey results. Minecraft works in integers, so each of the numbers had to be rounded as such. Two of the coordinates were basically on top of each other, especially after rounding, so I generated a random number between 1 and 100, similar to that in the surveys, and I subtracted it from the coordinates so that they weren't on top of each other, the two of them. This is the graph of my center and points. Next, I had to build things in each of the locations. I went along the outskirts and built two welcome centers, like what's at state borders, and a souvenir shop, though the souvenir shop only has one banner since it's the main attraction. For some reason, the banner didn't show right in the replay. This is what it's supposed to look like. This gives me 3 out of the 13 builds. I then went to the other noticeable outlier of the group. I knew I wanted to take the long, narrow strip of the build and turn it into a wheat farm, so I made a little farmhouse. The pigs didn't spawn in the replay, but they do exist. So does an armor stand with clothes on it. After the farmhouse, I made a small house and a horse stable. Originally, the horse stable was going to be another house, but I decided against it to give more variety. Going back to the bit about running out of time, recording each of the houses being made was becoming very inefficient, so I ended up switching to screenshots. In the end, I built another house, a church, a hotel, a wheat stand, a meat stand, an older house, and a city hall jail combination. It's glorious. And also a Christmas tree. If I was smart, I would have stopped there, but I don't know when to quit. So, 50 hours before the due date, 9 p.m. at night, I started work on a giant centerpiece that would float in my sky. I wanted it to be very bright, eye-catching, and non-man-made looking, not necessarily natural looking. Constructing spheres is not something I have much practice in. I'm fairly good at making the 2D circles, I'd like to say, which is what I did first, make the same circle along the X, Y, and Z axes. The difficult part is filling it all in. I've only practiced this like twice. In the end, I like what I built. It's a little oddly shaped, but it's pretty good. Minecraft actually has their x-axis as their north-south, and in my head, I look at a rectangular graph on Desmos and see the x-axis as east-west. So the ball in the sky is actually misplaced. I had to move it. It was at 1233, which is what the coordinates on Desmos were. But in Minecraft, it switches the y and x because the north-south is the east-west. So the actual coordinates I had to move it to was 3312. I did it fine with all of the buildings. It was just the centerpiece. So if it looks weird in the footage, that's why the screenshot is the correct one. The very last things I did, purely for aesthetic reasons, was bone meal all the grass to give tall grass, ferns, and flowers, and add some paths using a shovel. All the empty space looked really bad to me, so I changed it. Here are the screenshots of the final product. I'll show a few clips of me flying through it as I give the summary. Overall, I used 3 main concepts in this project. I designed the first tower using a sine graph and knowledge of how sine graphs work in unit circles. I changed the frequency of this graph to better suit my liking. I then got 3 points from this structure and used them to construct a triangle using law of cosines to get the angles, and then finding a center of the triangle with angle bisectors. Finally, I collected polar coordinates from a survey, converted them to rectangular coordinates, and shifted them to the offset center to get the build locations that I would need. All of this may sound very simple, but I have put several hours into this project every day for 20 days. I think the longest I worked on it in one sitting was 12 hours, with 14 hours being the total time I spent on it on that day. So this isn't something I just pieced together in 10 minutes. I did put effort in it. Overall, I like how this turned out. I didn't automatically know what was going to go where. I didn't know how I wanted it to be. So this could have been a lot worse. This is a good build. This is better than what I usually build. I'm proud of it. This is the end of my project. Thank you for watching. Fun trivia. It is 9:57 the night before it is due. Right now, I'm very sleep deprived. If my tone seems very flat in these voice recordings, that is why. It's not because I don't care. Trust me. This was really fun. Thank you for giving me the opportunity.